For estimation of glucose. The estimation of glucose can be done in different methods, modern methods and classical methods. The modern methods, including that HbA1c, that is a glycosylated hemoglobin, can be measured and quantified by using of HPLC. The classical method, you can quantify that the blood glucose by using of POD method. Also, you can use by using of dinitrosalicylic acid method to quantify the glucose which is present in our blood. So this blood glucose is very, very important significance character to correlate that clinical evidences. The blood glucose, the normal blood glucose in the empty stomach, it should be 80 mg per deciliter into 120 in the Asian population. 120 mg of per deciliter of blood glucose can be considered as a normal, not diabetic. The after food postprandial random blood glucose, it should falls between 120 to 140 mg per deciliter. These are all that the quantification can be done by different methods. Among the different methods, today we are going to discuss that the glucose estimation by dinitrosalicylic acid. Little bit we need to know that the chemistry about what is reduction and oxidation. So that reduction and oxidation, so this is the reducing and non-reducing sugar. Reducing sugars can be considered as a removal of oxygen from the glucose or fructose or whatever it may be, the reducing carbohydrate which we were already discussed. And this reduction, it's removal of oxygen or adding of hydrogen ion, also the gaining of electrons. This sharing of electrons between that dinitrosalicylic acid and the reducing glucose. Now the reducing glucose, as you can see here, the reducing glucose, if the H plus ion, if it is represented in the up and hydroxyl ion, it's represented in the bottom arrangement in a Horath position in the pyron ring, and this is called it as alpha-mer. If it is a OH is arranged in the up and H plus is the bottom, this is called beta-mer. So that all the glucose which we are consuming as starch, the starch is considered as an alpha-meric glucose. This alpha-meric glucose, if it is reduced in presence of reducing agent and it become that removal of oxygen and adding of H plus ions, then it become that if you see that here that H and OH, after removing of one H plus ion, removing the aldehyde group, the first carbon of glucose, the aldehyde group, in this aldehyde group, it's a one H is getting removed and it becomes double bond O. The removal of H plus ion can be added and taken up by the dinitrosalicylic acid. And also if you see that the galactose, if you drink that the milk does contain that the equal amount of glucose and galactose, that the galactose also does have that the first carbon is aldehyde carbon, aldose sugar. This aldehyde group can be reduced and to become that O double bond and H, the aldehyde group get changed. And if you take that the fructose sugar, this fructose sugar also can have that the functional group is the keto sugar. In this keto form, in the second carbon of the keto, it becomes reduced and the reduced sugar can be quantified. So based on that, if you want to quantify the glucose, you can use the dinitrosalicylic acid. That oxidified dinitrosalicylic acid, it's a ortho meta para. Or maybe first carbon, second carbon, first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. In this sixth carbon ring, the first carbon does contain carboxylic group and the second carbon does contain hydrogen group and third carbon does contain nitro group. So third and 5 is the 3 and 5 position of carbon dinitrosalicylic acid. This dinitrosalicylic acid, without adding of any sugar or reducing agent, then it become that yellow color. So once after reduction, so this reduction, that reduction can be defined as a removal of oxygen or adding of hydrogen. That hydrogen comes from the glucose, reducing sugar. Oxidation of glucose takes place. In this case, adding of oxygen or removal of hydrogen ions from the glucose, and this hydrogen ions can be added in this position. If it is a glucose reducing sugar, if it is provide H plus ion, this the third carbon of nitrate group NO2, it become NH2. This NH2 can be a typical character to convert it into orange red color. So this orange red coloration of this yellow, after that the mixing of the amount of glucose can reduced into removal of H plus ion. This H plus ion can be received by 3,5-dinitrosalicylic acid and it become 3-amino-5-nitrosalicylic acid. This 3-amino-5-nitrosalicylic acid, it become that orange red color. This orange red color can be quantified by UV visible spectroscopy as well as in the calorimeter. The amount of this color is directly proportional to that of the amount of H plus ion that the glucose reduced into provide that H plus ion that can be accommodated by the 3,5-dinitrosalicylic acid. It can turned out into 3-amino-5-nitrosalicylic acid in the orange red. If it is more amount of orange red color in your solution, it is representing as a amount of glucose which is present in your sample is very high. If it is a less amount of orange red turned out, it is representing as a less amount of glucose which is present. Why? Because it is not receiving H plus ion, the 3,5-dinitrosalicylic acid DNS, it is not reduced into this orange red color. So this can be quantified, and after quantification you can measure the amount of glucose which is present in your blood. The principle which we were discussed now is oxidation of aldehyde group of glucose, reducing sugar and it become oxidized and in the carbonyl group. Once after oxidation and reduction can be done by 3,5-dinitrosalicylic acid, the molecule comes from that oxidation, loss of electron, adding of oxygen and recovery of removing of H plus ion from the glucose that can be accommodated by 3,5-dinitrosalicylic acid and it become orange red color. So this is the principle. What are the reagents which is required for doing this particular estimation of glucose from our blood? So the solution A, we need to prepare 300 grams of sodium potassium tartrate in about 500 ml of distilled water, and then solution B, 10 grams of 3,5-dinitrosalicylic acid can be dissolved in 200 ml of 2 normal sodium hydroxide solution. After preparation of A, solution A and solution B, then you can prepare readily to mix both the solution A and B and make up to 1 liter. Now dinitrosalicylic acid reagent is ready. So to compare that the reference solution, the standard glucose has to be prepared. You can prepare that the standard glucose has a 1 mg per ml concentration, that is equal to 1000 microgram per 1000 microliter. If you take 1 microliter, that is equal to 1000 microgram, 1 microgram. 1 microliter is equal to 1 microgram. So how to do this? Just take that the 7 clean dry test tubes and pipette it out the standard sugar, that is a standard glucose, 1 mg per ml concentration or 0.1 grams in 100 ml, that is 100 mg in 100 ml, that is equal to 1 mg per ml concentration, and pipette it out the sugar solution in different test tubes and make up to volume of all test tubes in 1 ml with distilled water and add 2 ml of DNS reagent to all the test tubes, and then you take it to put it to the cotton or maybe aluminum foil or marbles cover and put it into water bath for boiling, and 5 minutes allow to boil. After boiling, take the test tube out from the water bath and cool it to room temperature and make up to 10 ml by adding of 7 ml of cooling water. And once after make up to 10 ml and mix thoroughly with the Vortex mixture, and after mixture you go and read 540 nanometer against a blank and take the reading and plot the value with the graph sheet. X-axis is concentration of different concentration of the glucose and y-axis different concentration of the OD value which you got for the concentration of the glucose, and with that you just tabulate the amount of glucose in the different concentration of the glucose how much volume should be taken from the stock